So we have left with only two programs, that is a whole part and the controller pattern. Those two are program that I need to explain. Just I'm going to explain only the seventh program as of now. Okay, so the seventh program is based on a pattern. So when we are using a whole part, what does this whole part pattern indicates? So it is basically an aggregation of components. That means, so in this program we are trying to use the concept of aggregation. I gave an example of a car, right, while explaining in a theoretical part. For a concept of aggregation, what we are trying to use, so the car is made up of a engine, wheels, brake, clutch, so all these things, when you are combined together, we can identify as a one particular component. So that aggregation of all this component, you are calling that object as a car. So here when we are trying to utilize a whole part pattern, it is basically on this constituents of the parts, how the parts are being made up of, so how they are going to collaborate with each other, so what are the functionality of each and every part, so how we can have an access to the parts, whether it can be accessed directly or indirectly. So all these things we are trying to observe with respect to the whole part pattern. So there is the other name of a whole part pattern is a composite pattern. So why we are calling it as a composite pattern? Because we are identifying the small parts. So all these parts we are trying to combine together, where each and every functionality of every part is being encapsulated, and we are trying to combine that as a whole, or we are looking that as a one singular object. That's the reason the earlier name for a whole part pattern, we call it as a composite pattern. So here we are using the context as a implementing the aggregation of objects. We are trying to identify different objects and how to implement these, how to identify these objects in a different way, that we are trying to organize in a particular manner, that we are trying to implement with respect to the whole part pattern. Next thing is we need to define a problem and the solution for this pattern. So the problem that we are identifying is, we are trying to divide the entire problem into the smaller objects. So these smaller objects, we are trying to identify whether it can support a reusability, changeability, or you can have a combination of different constituent parts. So all these things we are trying to observe. So and when you are combining all the smaller parts together, or when you are trying to aggregate all this constituent part together, so how the object is going to behave, that we are trying to identify with respect to the problem. So the solution that we are providing for a whole part pattern is, the first thing is, we need to identify the assembly of, we need to identify the relationship between the different parts. So how the parts has to be identified, what are the different parts, so how we are trying to assemble all these parts. So when you are when you are combining all the parts, whether it is going to affect the internal structure of the pattern, that we need to identify. So here the main thing is, it is like a container contains relationship. So the whole is a container where the parts are the contents in that container. So it is going to provide its own working, has to, such as to see as a entire container. So that's the main objective of this whole part. So here when we are trying to organize the relationship between objects, we are trying to identify what are the different functionalities of each and every part. So whether the members are accessible, whether they are iteratable, whether they are going to perform the different operation, whether it is an individual member or it is a dependent. So that has to be identified properly. The structure of the pattern contains two participants. contents. One is a whole and one is a part. So what is the working of a whole? The whole represents the entire objects, which is a combination of all the aggregation of all the objects. That is what we call it as a whole. I said when you say car, the car you are looking at as an entire thing that represents a whole. So what are the contents of the car? So now the car will become a container. The car has a different contents. What are the contents of the car? So it can be a clutch, brake, accelerator, steering, seats, engine, wheels. So all these things will become a parts of the part. All these things will become a parts. So or we can say it is the contents which are contained in a container. So when we are identifying all these parts, so it should coordinate with each other. So when you are trying to when a car is moving, when you are trying to apply a brake, so it should apply the brake to stop the car. That's the main intention. That means there should be a coordination between every part. So that is what the whole is going to do. Next thing is part. So each and every part provides its own intended services. Whatever the services that we are specifying, all the services will be specified by individual part and it will return back the result. I said the brake, right? When you are applying the brake, so what is the use of a brake? To stop the moving car, right? So it is going to do its own parts. So like that, whatever the services that has been intended, all the services will be carried out by the part. So next, what we are having, we are trying to use a use case diagram. In a use case diagram, what we have a client and we have a eclipse as a object. So eclipse is a polygon object. So whatever the eclipses are there, so that you are trying to add it to the geometrical objects. So what the client thinks is, the client thinks is to add the eclipse into the system, and the client want to have a printout of all client want to print all this eclipses. These are the two different things that a client want to do. So now how do we represent that? So we can represent that with respect to the two use cases. One thing is you want to add the eclipse and you want to add the, you want to take a printout. So these are the two different things that the client want to do with respect to an eclipse. So here what we are trying to use, we are trying to use a different, in a class diagram we are trying to use an interface. So through the interface we are trying to print the eclipse. So we have an interface name called as a graphic, where print is a function, and we have a composite graph where we are using the realization between a graphic class and a composite graphic, where we are trying to add, print, add, and we are using a constructor called as a composite graphic. And we have a program called program class, where it's a main class, and we have a eclipse class. So in the eclipse class we are trying to redefine the print class, and we are using a constructor here. So what happens, this interface is going to realize between these two classes. So in a sequence diagram, what we are using a different objects. So one is a client, one is a graphic class, composite graphic class, and eclipse. So what does the client want to do? The client want to print the different graphics. So he will request for a graphic class to print the object. So now what does the graphic class will do? So now the graphic class has two options. One is a add option and one is a print option. So what the graphic class will do? It will invoke the add class, and it will pass the different objects, that is E1, E2 and E3 are the different types of eclipses or different eclipses that the client insists to draw the eclipse. So those parameters will be passed to the add class and it will be sent to the composite graphic class. So next what happens, again the client want to add the eclipse to the system. So he will request one more he is going to invoke once again the add operation and he will request to bring one more graphic. So through the graphic class, so what happens, graphic object, so what happens, whatever the object that you are passing has a G1 and G2, so that you are passing to the add class with the help of the objects. So what happens, these eclipse will be drawn by using a composite graph. So once the graph is being drawn, so next the client want to take a print of that graph. So what happens, it will invoke the print method. So since the graphic is the interface and this graphic class is being defined in a eclipse class, so what happens, it will send a message to the eclipse class. So what the eclipse class will do, it will print the whatever the objects that has been drawn, so that will be printed. So next, in a collaboration diagram, so we have a client, graphic class, composite graph and a eclipse. The client will ask to print the graphics. So what the graphic class will do, it will add the eclipse and it will add the eclipse and it will send to the composite graph. So what the composite graph will do, it will invoke the eclipse class and it will try to print all the eclipses. So how much ever the eclipses that the client is requesting, those many number of times the eclipse will be drawn. So next we have an activity diagram. So in the activity diagram, we have from the initial state, the client will be initiated. That once the client sends a request, so what happens? The request will be sent to the add component, and so the components will be added and the components will be printed. So you can add instead of add component, you can also use it like add eclipse. So after adding the eclipse, so it will move to the print. After printing, no other cases are there. So we are trying to end the activity there. So that is how activity diagram is going to work. So when we are coming for the implementation part, what we are using, we are trying to use a list class. Okay. So we are taking that entire graphic class in terms of a list. So we need to utilize the package called as a list, array of list. So since composite graph, since we have a graphic class as an interface, this composite graph implements the graphic class since the print method is being defined in a graphic class. So here we need to create a list. So whatever the number of requests that the client is asking, that has to be taken in a form of a list class. So where we are using a for this list class, we are having a object called as a child graphics, which will be of the array type. So next what we are using a print method. In a print method for each and every graphic till the child graph, whatever the number of lists that the user has given, number of eclipse that has been given, so up to that. So here we are not specifying for I is equals to 0, I less than 10 or anything. So instead of that, we are speaking in terms of objects. So for each and every graphic object up to the child graphic, whatever the number of lists that has been requested, so up to that number of requests, so what it has to do, so through the graphic object, it has to be printed. So how many ever times that the graphic has to be added, eclipse is being added, So those many ellipses has to be drawn. So that's the reason here we are using a graphic object. So the graphic dot print we are trying to use. Next, what we are using? We are using the add as an operation. In a add operation, what we are using? We are passing the object as a graphic. Why we are using object as a graphic? Because everything we are, whatever the list that has been created, everything will be taken care in terms of graphics. So which will be in terms of a list. So that list object we are using, and we are adding the graphic. That means whatever the number of times that the user has given a request, so those many graphics has to be drawn. That's the reason here we have written a statement child graphic dot add graphic. So when each and every time it will see in the list till the end of the list, it will print all the eclipses. So next, what we have a ellipse class. So in a ellipse class, what we are using, we are ellipse class will be implemented on implements a graphic class, since graphic is a interface. So between a ellipse class and a graphic class, what we have used an realization. Whenever there is an interface keyword comes, so when you are trying to give an association to the other class from the interface class, so it should be always a realization. So here what we are doing, we are just uh, printing the we are using a printout statement that it is printing an ellipse. That's it. We are not actually we are not printing the actual ellipse shape. Instead, just we are trying to use a printout statement, and once that method is being invoked, so what happens? It will print that message. We are not using any applets here again. So we have used a graphic.java class. In a graphic class is the interface class. Just we are defining a print method. So next, what we have a main method. So the main method we are calling it as a program or a prop. So here we are defining the main class, and for a ellipse class, we are defining a different objects, and for a composite graph, we are defining a different objects like G1, G2. So these are the different objects that has been identified. So now what we are trying to do, we need to draw the ellipse for each and every object. So we are using a composite graph. So through the use of composite graph, we are calling the AND method, where the AND method is available in the ellipse class. So when you are passing the message as E1, so what happens? So it will draw the first ellipse for the object G1, and again for the same object we are drawing a one more ellipse class, and we have created a one more object called as a G2 for a composite graph. So again we are trying to add the ellipse, and the object is E4. Now after adding this two, we have left out with one more object called as a G. So again for a G, what we are trying to do, we are trying to add both the ellipses, that is G1 and G2 we are trying to add. So after passing this, so we need to print that ellipses. So to print that ellipse, what we are using the G dot print. So when the G dot print is invoked, so in a print statement, what we have given, just we have given an ellipse. So those many number of times, how much object we have created, we have taken a 4 different ellipses. So 4 times the ellipse has to be printed, since we are calling that through the G dot print. So this is how the ellipse will be. This is how the output will be there for a whole part pattern. So you have any doubt? Seema?
Yes, ma'am.
Any doubt, ma, with
No, ma'am.
respect to that?
No, ma'am.
No? Okay, that is about a whole part pattern. So if you are having any doubts, you can ask me. Okay? Check. Tell me if you are anyone any doubts.
No, ma'am.
Naina?
Yes, ma'am.
Doubts ಇದೆಯಪ್ಪ.
ಇಲ್ಲ, ma'am.
Okay, I will let you know what are the programs are there either tomorrow or Monday class. Okay, for the
Yes.
23rd and 24th, right?
ಲ್ಯಾಬ್ ಇಂಟರ್ನಲ್ಸ್.
Huh?
ಮ್ಯಾಮ್ ಲ್ಯಾಬ್ ಇಂಟರ್ನಲ್ಸ್ ಹೇಗೆ ನಡೆಯುತ್ತೆ ಮ್ಯಾಮ್?
That's what we need to find out. Either we need to ನಿಮಗೆ ಪ್ರೋಗ್ರಾಮ್ಸ್ ಕೊಟ್ಟು ಯು ರೈಟ್ ಇಟ್ ಇನ್ ಅ A4 ಶೀಟ್ ಅಲಾಂಗ್ ವಿತ್ ಫ್ರೆಂಡ್ ಶೀಟ್ ಅಲ್ಲಿ ಇದು ನಿಮ್ಮ ನೇಮು ಯು ಎಸ್ ಅನ್ನು ಹಾಕಿ ಯಾವ ಪ್ರೋಗ್ರಾಮ್ ಬರುತ್ತೆ ದಟ್ ಪ್ರೋಗ್ರಾಮ್ ಯು ರೈಟ್ ಅಂಡ್ ಲೇಟರ್ ವಿ ವಿಲ್ ಯು ಕ್ಯಾನ್ ಪುಟ್ ಅ ಸ್ಕ್ಯಾನ್ ಕಾಪಿ ಆಫ್ ದಟ್ ಟು ಅವರ್ ಮೇಲ್ಸ್ ದಟ್ ಕ್ಯಾನ್ ಬಿ ಡನ್. So based on your written write up, we can provide the marks. So for this, you can use a star. If you have installed star in UML, you can draw the diagrams and show it to me.
ಮ್ಯಾಮ್ ಅದು ಅವೈಲಬಿಲಿಟಿ ಇಲ್ಲ ಅಂದವ್ರಿಗೆ ಫೋನಲ್ಲಿ ಮಾಡ್ಬೋದಾ ಮ್ಯಾಮ್ ಅದು?
ನೀವು ಫೋನಲ್ಲಿ ಮಾಡಿ ತೋರಿಸ್ಬೋದಮ್ಮ.
ಓಕೆ ದೆನ್ ಫೈನ್. ಬಿಕಾಸ್ ಸಿಸ್ಟಮ್ ಅವೈಲಬಿಲಿಟಿ ಇಲ್ಲ ಅದಕ್ಕೋಸ್ಕರ ಮ್ಯಾಮ್.
ನೋಡಿ, ಯಾಕೆಂದ್ರೆ ನಿಮ್ಮ ಫೋನ್ ಸಪೋರ್ಟ್ ಆಗ್ಬೇಕಲ್ವಾ, ಅಷ್ಟು ಕೆಪಾಸಿಟಿ ಇರಬೇಕು. ಯಾಕೆಂದ್ರೆ ಇದು ಡ್ರಾಯಿಂಗ್ ಟೂಲ್ ಅಲ್ವಾ, ನಿಮಗೆ ಜಾಸ್ತಿ ಬೇಕಾಗತ್ತೆ. That's the reason. So either you can go with a write up and you can send it to me. Okay, once you we can make a video enabled. So once you show the program, then you can draw the program and ನಿಮ್ಗೆ ಹೇಗಿರೋ ನೆಟ್ ಬಿನ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಿದ್ದೀರಲ್ವಾ, ಜಾವಾ ಪ್ರೋಗ್ರಾಮ್ ಅದ್ರಲ್ಲಿ ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡಿ ತೋರಿಸ್ಬೋದು. With the output, you can show the output screen to me.
ಓಕೆ ಮ್ಯಾಮ್, ಟೀಚರ್ಸ್ ಎಲ್ಲ ಕಾಲೇಜಿಗೆ ಹೋಗ್ತಿದ್ದಾರಾ ಮ್ಯಾಮ್?
ಏನಮ್ಮ?
ನೀವೆಲ್ಲ ಕಾಲೇಜ್ ಹತ್ರ ಹೋಗ್ತಾ ಇದ್ದೀರಾ?
ಹಾ ಅಮ್ಮ, ಎಲ್ರೂ ಹೋಗ್ತಾ ಇದಾನ ನನ್ ಬಿಟ್ಟು.
ಓಕೆ, ಡೈಲಿ ಅವೈಲಬಿಲಿಟಿ ಇದಾರೆ ಹಾಗಾದ್ರೆ ಟೀಚರ್ಸ್. ಇನ್ ಕೇಸ್ ನಾವು ಹೋದ್ರೆ ಸಿಗ್ತಾರಲ್ವಾ ಮ್ಯಾಮ್?
ಸಿಗ್ತಾರೆ, ಬಟ್ ನೀವು ಹೋಗ್ಬೋದೋ ಏನೋ ಗೊತ್ತಿಲ್ಲ ಅಮ್ಮ. ಯಾಕಂದ್ರೆ ಎಲ್ಲ ಟ್ರಾವೆಲ್ ಹಿಸ್ಟ್ರಿ, ಎಲ್ಲ ಟೀಚರ್ಸ್ದು ಟ್ರಾವೆಲ್ ಹಿಸ್ಟ್ರಿ ಕಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡು ಹೆಲ್ತ್ ಚೆಕ್ಅಪ್ ಮಾಡಿ ಆಮೇಲೆ ಒಳಗ್ ಬಿಡ್ತಾ ಇದಾರೆ.
ಓಕೆ,
ಬಟ್ ನೀವು ಕೇಳ್ಬಿಟ್ಟು ಹೋಗಿ.
ಅದೇ ಸ್ವಲ್ಪ ಸಾಫ್ಟ್ವೇರ್ಸ್ ಹಾಕೋಬೇಕಿತ್ತು ಮ್ಯಾಮ್. ನಾವು ಇನ್ಸ್ಟಾಲ್ ಮಾಡಿರೋದು ಯಾವ್ದು ಕರೆಕ್ಟ್ ಆಗಿ ವರ್ಕ್ ಆಗ್ತಿಲ್ಲ. ಪ್ರೋಗ್ರಾಮ್ಸ್ ಮಾಡಕ್ ತುಂಬಾ ಕಷ್ಟ ಆಗ್ತಾ ಇದೆ.
ಬಟ್ ಇನ್ ದಟ್ ಕೇಸ್ ನೀವು ಹೋಗ್ಬೇಕು ಅಂದ್ರೆ ಕೇಳ್ಕೊಂಡು ಹೋಗಿಪ್ಪ. ಮತ್ತೆ ಯಾಕೆಂದ್ರೆ ಹೊರಗಡೆ ಬಿಡ್ತಾರೋ ಇಲ್ವೋ ಗೊತ್ತಿಲ್ಲ, ಅದಕ್ಕೆ ನೋಡ್ಕೊಂಡು ಹೋಗಿ ತೊಂದರೆ ಮಾಡ್ಕೋಬೇಡಿ ಅಷ್ಟೇ. ಸ್ಟಾರ್ ಆಮೇಲೆ ಇದಾಗಿಲ್ವಮ್ಮ?
ಇಲ್ಲ ಮ್ಯಾಮ್, ಇದು ನಾನು ನೆಟ್ ಬೀನ್ಸ್ ಇನ್ಸ್ಟಾಲ್ ಮಾಡಿದ್ದೆ. ಅದು ಫುಲ್ ಯಾವುದೇ ಪ್ರೋಗ್ರಾಮ್ ಮಾಡಿದ್ರು ಆಡ್ ಆನ್ ಲೈಬ್ರರಿ